Now, our next bit is this. This is our previous work. Log base b of b raised to some power. Again, this is the extremely unofficial way of writing this. Don't put this in your textbook, it won't get published. But log base b of b to the stuff. When you apply logarithms and exponentials in sequence, it is as if they cancel and you're left with the argument, the stuff. So what that means is we start here, the exponential goes in this direction, and then the inverse comes back in this direction. But we could have started here and done this way first and then this way second. So not only does f inverse of f of x cancel and give you just x, we also have f of f inverse. The point is, it doesn't matter what order you did this. In the previous example, we had third root and third power. If you do third power, then third root, they cancel. But the other sequence is just as valid. If you do third root and then third power, they also cancel. So which one happens first and which one happens second is irrelevant, as long as they are inverse functions and as long as they are immediately in sequence, then it is as if they cancel and you're left with just the argument. So not only does logarithm of exponential, this is exponential first, remember parenthesis, exponential first, then logarithm. You may also do logarithm first, then exponential. So you may also reverse the sequence. Here's what that would look like. If you have log base b of some stuff, but then you take b and raise that to this power. This is exponential of logarithm, this is logarithm of exponential. Log of exponential, they cancel, you're left with just the stuff. This is exponential of logarithm, they cancel, you're left with just the stuff. And there's nothing magic about what value of b you're allowed to use. So log of exponential cancels, you're left with the argument, the stuff. Exponential of logarithm, they cancel, you're left with just the argument, you're left with just the stuff, as it were. And so, what we can say now is this. We can say if I have log, suppose b is equal to 3. Log base 3 of 3 raised to the power x minus 1. Right? Log, exponential, when you apply them in sequence, immediately in sequence, it is as if they cancel, you're left with just the argument. That's this piece. But if you do the log first, if I first do logarithm of, let's say, log base, let's suppose we do log base 5, of x squared plus 4. So that's a value. But now if I take, it must be the same base, just like the bases must be the same here. If I take 5 and raise it to that power, now I have exponential logarithm. So if 5 raised to this power, though it is as if those cancel, you're left with just this argument. This is x squared plus 4. So logs and exponentials cancel out. Logs and exponentials cancel each other out. Log cancels exponential, exponential cancels logarithm. And so here's how we're going to use that. If you have an equation that contains a logarithm and you want to get rid of it, the way you get rid of a logarithm is using an exponential, because that's what cancels it. If you have an equation that has an exponential and you want to get rid of it, the way you get rid of an exponential is to logarithm. Logs and exponentials cancel each other out. It's just like if you have an equation involving third root and you want to get rid of the third root, you do third power, because third power is the inverse. Well, now if you have a logarithm, log base 3 of, let's say, x is equal to 10, we'll say. Right? Log base 3 of 10. We want to get rid of this logarithm. Well, how do you get rid of log base 3? The way you get rid of log base 3 is you take 3, raise it to the left-hand side. Whatever you do to one side of your equation, do to the other side. So, this means if you take 3 and raise it to the left-hand side, that must equal 3, raise that to the right-hand side. Now what happens here is they cancel, and you're left with just x by itself. That's the key notion. Now you would need to compute 3 to the 10th power, which is a gigantically huge number. But the point is, this is how you get rid of this logarithm. The way you get rid of a logarithm is you exponential both sides. The way you get rid of exponential is you logarithm both sides. So these are the tools. If you have one, then the other is what you use to get rid of it. It doesn't matter which one you have, you use the other to get rid of it. So we'll go through this procedure several times in several different equation types, and you should get the hang of it, and it should become really almost second nature. That to undo logarithm, use exponential, and to undo exponential, use logarithm.